Welcome back as we move on to demonstrate the first test procedure, namely a no-load test. Setting up the starter motor is an important part of all tests, so let's take a moment to do this properly. First, the motor must be settled onto the support frame and positioned in such a way that the pinion gear will engage the ring gear. The motor is now moved to obtain a clearance of approximately 2 or 3 millimeters between the flywheel face and the starter pinion housing. The unit must then be securely clamped. Once secure, the heavy battery cable is attached to the solenoid battery terminal and secured using a nut. Never just hang this cable onto the stud, or it will burn away the threads. The small start switch cable is connected to the SW lug of the solenoid, and that's all the connecting we need to do. To check the operation and setup, make sure that the flywheel is free to rotate. The load knob must be turned fully counterclockwise to release any load on the flywheel. Connect the power via the isolation switch, and keeping your hands well away from the flywheel, press the start button. Observe if the pinion meshes fully into the ring gear. Now release the start button and ensure that the pinion disengages instantly from the flywheel. Assuming that our setup is correct, we'll continue with the no-load test. Switch on the mains power in order to activate the tachometer. Now we operate the starter and note the amp reading, the voltage reading, and the tachometer reading. This test must be done within 15 seconds to avoid overheating the motor. The conclusions of this test are as follows. The amperage draw should be according to specification, which on a small motor like ours would be around 50 amps. The voltage should not fall below 9,5 volts during the test. The motor speed will, for the average motor car, be around 8,000 RPM, yielding a cranking speed of around 600 RPM to the engine's crankshaft. These figures may be provided by the motor's manufacturer. If the amperage goes too high and the shaft speed is low, then the motor probably has worn shaft bearings or a bent armature shaft. Electrical insulation problems in the armature will give similar results. Failure to operate, but with a high amperage draw, is most usually a grounded field winding, or in some cases, a completely seized armature. Failure to operate at all, with no current draw, can be poor or no brush contact to the commutator, open circuits in the fields or armature windings, or the most common case, a faulty solenoid unit. A high shaft speed and a high amperage draw would indicate that the field coils have shorted. It is suggested that you now perform a no-load test using the procedures we have demonstrated. After the break, we shall deal with solenoid checks.